Good evening. Welcome to the Helena Math Guy's explanation of infinite limits. What we're going to be looking at on the screen here using GeoGebra is going to be some interesting functions. I'm going to start with function 1. f1 of x is 3 divided by x minus 4. You can see the graph there. Let's look at the vertical asymptote. It's pretty easy to figure out where that vertical asymptote is going to be. There it is. It's right at 4. So think about this. What is the value of this function, f1, this function right here, as x approaches 4, and I'm going to approach 4 from below. So I'm getting closer and closer. Ooh, look at that value. It looks like it's going to negative infinity, of course. Now we're going to approach infinity, or not approach infinity, but we're going to approach the value of x equals 4 from above. So I'm going to start with 12 and move down to 10 and 8 and 6, and I'm going to move closer and closer to 4. And what's happening to my value of the function? I'm going to positive infinity. So it looks to me like there's clearly the limit does not exist. Going from the left, I'm going to negative infinity, and coming from the right, I'm going to positive infinity. Again, two big values. Let's look at a different function. We'll turn that one off. Now I'm looking at f2. f2 over here, if you look on the left side of the screen, is 1 divided by 2 minus x squared. Let's adjust that vertical asymptote. I think you can look at the value of that function. Look up there. What do I put in for x to make it undefined? Clearly you can't divide by 0, and when x is 2, it's undefined. So there's the vertical asymptote. Now notice the behavior of this function. As x moves in from negative 4 to 2 to 0 and moves closer and closer to this value of 2, it's clear that the function's going to positive infinity. As x is moving to the value of 2 from above, the limit as x approaches f2 of x from 2, and x approaches 2 from above, that limit is going to positive infinity. So here we can say the limit, again, it doesn't exist, but you can be a little more specific. Consider the limit is equal to infinity. It's getting large without bound. Okay, the third function I want you to look at is negative 3 divided by x minus, or x plus 2 squared. Again, look at that. Tell me where the value of the vertical asymptote would be. What value would make that denominator 0? That's a good place to start looking for vertical asymptotes, though we know sometimes what we end up with is a hole in the graph or an undefined point. Yeah, there we are, x equals negative 2, and again the limit from both sides this time is going to negative infinity, and that kind of summarizes what we're talking about in the infinite limits. Thanks for joining me, the Helena Math Guy at 405 North Montana. Bye.